By default, Amazon MSK clusters aren't reachable over the public internet. This means that Kafka clients outside AWS, either on premise, inside Google Cloud, or even on your laptop, can't connect to your MSK cluster. You can overcome this with MSK Public Access. However, this requires modifying and directly exposing MSK brokers to the internet. Not a good idea. An alternative approach is Aklavity's Public MSK Proxy. It's a more flexible and controlled way of making your MSK cluster publicly reachable. As its name suggests, Aklavity's proxy is a proxy. Well, it's actually a group of proxies, which sit between your MSK brokers and an internet-facing network load balancer. These proxies understand the Kafka protocol and are able to route connectivity to and from the NLB and then MSK cluster. In this walkthrough, we're going to set up and test the Aklivity Public MSK Proxy. We'll take care of this in 4 steps. First, we'll set up an MSK cluster and create an appropriate MSK Proxy security group and IAM security role. If you have an MSK cluster, then you can skip over the first half of the step, but you'll still have to set up the proper security privileges covered in the second half. Next, we'll create a TLS server certificate for a sample wildcard domain that can be trusted by a local Kafka client. After this, the fun begins, and we'll actually configure and deploy the public MSK proxy. And last but not least, we'll test the public proxy by publishing messages and subscribing to a topic in our Amazon MSK cluster directly from our laptop. Before getting started, let's pull up the docs. Go to aklivity.io, docs, Amazon MSK proxies, public MSK proxy. You'll notice that there are 2 deployment options for the public proxy, development and production. The production guide covers setting up the Aklivity proxy with a globally trusted TLS server certificate, which enables you to use your own custom domain name when exposing your MSK brokers publicly. Here, though, we're going to be following the development guide, which instead uses a locally trusted TLS server certificate for the example wildcard DNS pattern star.aklivity.example.com. Let's jump in. In the first step, we're going to spin up an MSK cluster. To do this, we'll first have to create a VPC in which the cluster will be deployed. Open up your AWS Management Console, search for VPC, and click on Launch VPC Wizard. We're going to create our VPC subnets separately, so select the VPC only option. Given that this VPC will house our MSK cluster, we can get really creative and call it My MSK Cluster. Set the IPv4 CIDR to 10.0.0.16 and click Create. Alright, so now we'll add some subnets. On the left, navigate to Subnets, Create Subnet. In the dropdown, select the My MSK Cluster VPC that we just created, and we'll create 3 subnets in different availability zones. The first subnet we'll call My MSK Cluster 1A, and we'll set the IPv4 CIDR to 10.0.1.0.24, and the availability zone will be US East, North Virginia. Let's add the second subnet. It will be called My MSK Cluster 1B. Same region as the previous subnet, but US East 1B instead of 1A. And 10.0.2.0.24 for the IPv4 CIDR. Subnet 3 will be, you guessed it, My MSK Cluster 1C, deployed in US East 1C and with CIDR block 10.0.3.0.24. Click Create. We now have our subnets. Let's now create the Internet Gateway so that our VPC can communicate with the Internet. Navigate to Internet Gateways in the left menu under Virtual Private Cloud. Click Create Internet Gateway, and let's call our gateway My MSK Cluster IGW. We now need to attach the Internet Gateway to our VPC, so click on the Attach to VPC prompt up top and select the My MSK Cluster VPC under Available VPCs. Although traffic can be routed from the internet to resources in your VPC via an attached internet gateway, traffic cannot leave the VPC by default, so the route table must be updated. Under the Resources by Region section, select the Routes Tables resources box to show your route tables. Click on the route table associated with the VPC named My MSK Cluster to show the Details page. click the Edit Routes button in the Routes tab of the lower section and add a new route after all other routes with the following details: destination 0000/0, and for the target, let's find the internet gateway we just created and select it. Save changes. Now that we have a VPC, we can deploy an MSK cluster inside of it. So in the search bar, let's look up MSK and jump into the MSK Management console. On the left, expand the menu and select Clusters, Create Cluster. We're going to go with the Custom Create option and call our cluster Aklivity. You can obviously call it whatever you want though. To save some money, we'll choose the smallest broker type, T3 small, and let's drop the storage to 10 gigs and keep the default MSK configuration. Let's put the VPC we just created to work and select it to house our MSK cluster. Apply our 3 subnets. We're going to set up the appropriate security group in the next step, so skip it for now. And we'll take care of IAM later as well. All of this can stay as is. And click Create Cluster. Okay, great. We just initiated an MSK cluster. It can take up to 15 minutes for the MSK cluster to spin up, sometimes even longer. You can either take a coffee break or go to the next step where we will create the MSK Proxy security group. We need to create a VPC security group that will enable Kafka clients to reach the public MSK proxies, as well as allow us to SSH into their EC2 instances. In the left menu, scroll down to Security and select Security Groups. Click Create Security Group and let's fill out the Create Security Group form. We'll call our security group My MSK Proxy with a description, Kafka clients, and SSH access. Select the MSK Clusters VPC. Let's create 2 inbound rules. The first will be used by Kafka clients. Select port range 9094 and IPv4 anywhere as the source. The second rule will be for SSH. So select SSH, and for the source IP, select My IP. This will set the IP address of the current network you're on as a trusted source. This means that if you change networks, for example, you did the setup at work and then you try to SSH into the instances from your machine at home, it won't work. You'll have to add another SSH inbound rule for your home IP address. Click Create, and now we have an appropriate security group for our MSK proxy. We will now update the default security group of our MSK Clusters VPC to enable our proxy instances to access our MSK cluster. To do this, we'll have the default security group of the MSK Cluster VPC reference the MSK Proxy security group we created in the previous step. Open up the list of available security groups and look for the one called Default. You'll notice that there might be more than one. Select the one whose VPC ID matches that of the security group named My MSK Proxy. Scroll down and click Edit Inbound Rules. Add rule, Custom TCP, port 9094, source, custom. Scroll down, security groups, and select My MSK Proxy. Save. The MSK Proxy leverages several Amazon services, such as Secrets Manager for certificates and metering for billing. To grant it access to these services, we need to create a new IAM security role. In the AWS console, let's search for IAM. And then under Access Management, to the left, go to Roles and create role. We're creating a role for our proxies that run in EC2 instances, so we'll select EC2 under Use Case. The first permission policy that we'll add to our security role is metering. So let's type in Marketplace Metering, click Search, and select the first one, which ends in Full Access. Next, we'll clear the search filter so that we can search for the next policy that we need to add, which is related to AWS's Certificate Manager. Enter Certificate Manager and select Certificate Manager Read Only and the Certificate Manager Private CA Read Only policies. Again, clear the search filter and look up Resource Groups to add the Tag Editor Read Only Access policy. Let's name our role Aklivity Public MSK Proxy. Confirm that we have all of the appropriate policies, and click Create. We're not finished just yet though. We need to add one additional custom inline policy for the AWS Secrets Manager so we can retrieve the secret name for the wildcard certificate key, which in our case is wildcard.aklivity.example.com. If you're using a different secret name for your wildcard certificate key, then make sure to use it instead in the regular expression that we will be pasting. In the IAM console, let's select the Aklivity Public MSK Proxy role we just created. On the right, click on Add Permissions, Create Inline Policy. Select the JSON tab, and now go to the Aklivity docs and copy the JSON in the summary row in the table in the Create the MSK Proxy IAM Security Role section. Paste it in, click Review Policy, and give it a name of MSK Proxy Secrets Manager Read. Now we are done with creating the IAM security role that enables the required AWS services for the MSK Proxy instances. We now have an MSK cluster that is ready for a public MSK proxy. But before we install the proxy, we first need a TLS server certificate for the wildcard domain star.aklivity.example.com that can be trusted by Kafka client in our local development environment. Navigate to the ACM PCA Management Console and click Create CA to complete the Create Certificate Authority wizard. We need a root CA with the common name testCA. The other details we can leave blank. We'll keep the default RSA 2048 key algorithm, no revocation options, no tags, keep CA permissions as is. Private CA isn't free, so we'll click Confirm on Pricing and create the CA. Our PCA ACM has an ARN, Amazon Resource Name, that we'll need to subsequently reference, so take note of it. We now need to export the CA certificate. Select the test CA that we just created. I have a duplicate test CA, but you should only have one. Under Actions, select Get CA Certificate and export to a file. Note the certificate.cir file name location where you download the CA certificate. We also need to create a new key that will be used with the certificate and store the key in PKCS8 format. In this example, we will be creating the key for wildcard certificate with star.aklivity.example.com as the common name. Go to your terminal and copy-paste the command line code in the Aklivity docs under Generate the RSA Key section, which is found in the Create Server Certificate ACM resource page. Next, we need to create a certificate corresponding to the key, with the metadata about the owner of the certificate and the common name. This is done by first creating a certificate signing request. Again, in your terminal, copy-paste the next OpenSSL command and fill in the certificate info. You don't need a challenge password. Now that the certificate signing request has been prepared, it can be used to issue a new certificate signed by your private certificate authority. In this example, we issue the certificate to be valid for 365 days. You should choose a validity period that best suits your specific use case. In the terminal, paste the issue certificate command. Remember the CA ARN we noted earlier? This is where we need to input it. So let's go back and copy it and paste it. Tap Enter and you'll get back to the ARN of the newly signed certificate. Note it, as we will use this ARN along with the CA ARN next. Note, if you see the following error when attempting to run the command, an error occurred unrecognized client exception when calling the issue certificate operation, the security token included in the request is invalid, and make sure that you have retrieved and set your AWS credentials for CLI use. Now we need to create the secret value using the PKCS8 encoded private key as the secret value and with secret tag certificate authority ARN referencing the private certificate authority. and certificate ARN referencing the newly signed certificate. Paste the create certificate command into the terminal and make sure to input the two ARNs that we now have, one of the certificate authority, the other of the certificate itself. Tap enter, and we'll get a third ARN, which we will use in the next step where we will finally deploy the public MSK proxy. Keep the terminal window open as we will come back to it. All right, we've reached step 3 and let the fun begin. We have our MSK cluster, we have our certificate. Now it's time to configure and deploy the public MSK proxy. First, we need to subscribe to the product offering on AWS Marketplace. You can find Aklivity's public MSK proxy by either Googling Aklivity Public MSK Proxy, AWS Marketplace, and clicking on the first link, or by visiting the Aklivity website. Make sure you're signed into AWS and on the public MSK Proxy Marketplace, click Continue to subscribe. The public MSK proxy is delivered as a CloudFormation template, which makes it easy to deploy. Select the regular public MSK proxy option and continue to launch, and actually launch the CloudFormation template. This will open the CloudFormation wizard referencing the template. Click Next. Let's give our public MSK proxy a name. Again, we'll get super creative here and call it My Public MSK Proxy. Under Network Configurations, select the VPC in which the MSK cluster is deployed. Select all of the MSK cluster subnets. We now need to grab the wildcard DNS pattern for our MSK cluster bootstrap servers. Go to your MSK console to pull up the MSK cluster, and under Properties, select and copy everything following the B1. Paste it and add a star in front. Make sure there's a period after the star. Select the Aklivity Public MSK Proxy security role that we previously created, and select the My MSK Proxy security group that we also previously created. The Secrets Manager secret ARN for the TLS certificate private key is the ARN that we last generated on our terminal, so pull up the terminal and copy it over. The wildcard DNS pattern is star.aklivity.example.com, port 9094, and let's indicate the SSH key for which we set up the permissions in the My MSK Proxy security group. Click Next and create stack. It will take a few moments for the stack to be created and the MSK Proxy instances to launch. You can click the refresh icon to check on the progress of the underlying components, such as the proxies themselves, as well as the internet-facing network load balancer they are sitting behind, as they get deployed. Once the public MSK Proxy CloudFormation stack has launched, let's check that the proxy instances have been properly deployed and are running. To do this, we'll SSH into the EC2 instance in which the proxies are running. Go to the EC2 management console. You should see two instances that belong to the My MSK Proxy security group. These are the instances in which the proxies are running. Select one of these instances and copy its public IP address, which we'll SSH into. Open your terminal and SSH into the EC2 instance by typing SSH-I //.ssh/keypair ec2-user @ and paste the public IP address you just copied. Once you're in the EC2 instance, check the status of the MSK Proxy system service by using the command system control status mskproxy.service. If everything is working properly, your output should match what's on the screen, and the last line should have recorded usage for record ID. You should repeat this for each of the public MSK Proxy instances launched by the CloudFormation templates. All right, step 4, the final step. Now that we've validated that the MSK proxy is working, we can get to the fun stuff of actually trying it out. We'll do this by installing a generic Kafka client on our local machine, importing the private certificate authority, and configuring the Kafka client and local DNS. We then will use our local Kafka client to create a topic inside our MSK cluster, publish a message, and read it back. If you don't have a Java runtime installed, you're going to need one, so take care of that first. In your terminal, paste the wget command from the docs to install the Kafka client. Expand the folder and cd into the directory. When we created the certificate authority, we exported a private certificate to a file called certificate.sir, which we'll now need to import into our trust store. Run the keytool command in the docs. With the Kafka client now installed, we are ready to configure it and point it at the public MSK proxy. The MSK proxy relies on TLS, so we'll need to create a file called client.properties that tells the Kafka client to use SSL as the security protocol and to trust our private certificate authority as the signer of the star.aklivity.example.com certificate. Let's create the client.properties file in our text editor of choice and copy-paste the contents from the docs that set the security protocol and the trust store location. When using an example wildcard DNS, such as star.aklivity.example.com, then the DNS entries are set up locally. To do this, we first need to grab the DNS name of the network load balancer deployed by our MSK Proxy CloudFormation stack, so that we can look up the public IP addresses for the Bootstrap proxy names. Go to your CloudFormation console and open the MSK Public Proxy stack that we just deployed. Under Outputs, you'll see the network load balancer, and under Value is its DNS name. Select and copy it. Then go back to your terminal and run an NSLOOKUP on the DNS name. You should receive back the IP addresses of the Bootstrap proxy names. Open your etc host file and add these IP addresses and reference them to the Bootstrap server names. You can now use the Bootstrap server names b1, 2, or 3.aklivity.example.com 9094 when connecting to your MSK cluster from your local development environment. Awesome. We now have everything we need to see the proxy in action. By having our local Kafka client communicate with our MSK cluster to create a topic, publish, and then subscribe to the same topic. Let's create a topic called Public Proxy Test. Copy-paste the Kafka client command from the docs to your terminal. Make sure that you write out the TLS Bootstrap server names in the command. Boom, we just created a topic. So what exactly just happened? The Kafka client with access to the public internet issued a request to create a new topic. This request was directed to the internet-facing network load balancer. The network load balancer forwarded the request to the Aklivity Public MSK Proxy. The Aklivity Public MSK Proxy routed the request to the appropriate MSK broker, and the topic was created in the MSK broker. Let's publish a message now. Copy-paste the command and again make sure to populate the TLS Bootstrap server names. A prompt will appear. Let's create the message, my first event. Let's add another, my second event. Close the prompt, and now let's subscribe to the Public Proxy Test topic and play back the messages. And just like that, we have set up and verified public connectivity with Aklivity Public MSK Proxy.